The best preparation for tomorrow is giving your best today. Hello, my dear mechanical and civil champions. I welcome you all to this beautiful session of fluid mechanics, that is manometry, pressure equation. The topic is one of the most important topic for fluid statics, and it is the fundamental or the basic topic which you should have an understanding for if you want to clear the questions from the subject of fluid mechanics. All right. So please guys, do join me fast, and those who are already here, respond through the comment section if I am audible and visible to everyone. We will analyze or we will revise the concept of fluid statics, manometry through the questions only. And if you have any doubt, anything to ask, you are most welcome. You can always raise your concern through the comment section. So please do let me know if my audio and visual quality are fine, so that we can start. Can you guys hear me? I am not able to hear you. Just a second. Yes. Those who are watching me live, respond through the comment section if my audio and visual quality are fine, so that we can start. And please do mention if you are from mechanical engineering branch or civil engineering. Manometry involves the concept of Pascal law, very important law, and hydrostatic law. So we develop the pressure equation, or we write the pressure equation using these two laws, hydrostatic law. These are the two important laws which are used in developing the manometric equation or developing the pressure equation. All right. Before I start my session, this is my quick introduction for those who are attending the session for the very first time. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared the engineering services examination which is conducted by UPSC. I have worked in Steel Authority of India Limited for a couple of years, and I am quite comfortable in fluid mechanics, which is common for civil as well as mechanical engineers, and the other subjects are exclusive subjects for mechanical engineering only. All right. So if you want to connect with me, you can always use my official mail ID chandra.shekhar7@byjus.com, and it is beneficial for you if you join me on the Telegram. My Telegram link is, or my Telegram channel is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom of the screen. Right? And there is a beautiful session tomorrow at 7:30 p.m. The workshop will be conducted by Joshit sir. He is MTech from IIT Roorkee, having more than 5 years of teaching experience, and he will guide you to develop the right strategy which mostly the toppers used to follow if you want to clear the GATE examination with a rank under 100. So this free workshop, interactive workshop, is going to be very beneficial for all the students who are preparing for GATE 2024 examination. You just have to register yourself, and do register yourself before attending the session, and do ask your friends also to join this workshop. All right. Shall we start our session? Are you all ready? So we will discuss some beautiful numericals, hand-picked numericals. We will start with the simple questions to develop the confidence, to develop the concept, and then gradually we will enter into the more difficult questions. So this is how we are going to proceed. But before I start my session, let me ask you a simple question. In case of static fluid, how the pressure varies with depth? Will it vary linearly or not? Your answer must be yes or no. Please do write Y for yes. If your answer is yes, please do write Y in the comment section. If your answer is no, please do write N in the comment section. Yes. Do let me know, in case of static fluid, the variation of pressure, is it linear with depth or not? I am waiting for your response. I am not able to see your comments. Are you writing or not? Anybody is writing in the comment section or not? Can you guys see my comment? Yes, Prabhat. What about others? I am waiting for your response. Yes or no? In case of static fluid, you must have heard about the hydrostatic law. I have already told you there are two very important laws in manometry. One is the Pascal law, that is also applicable to a static fluid, and another is the hydrostatic law, that is also applied to the static fluid. But Pascal law talks about the variation of pressure in a horizontal plane. And according to Pascal law, the pressure remains same throughout the horizontal plane in case of static fluid. And hydrostatic law talks about the variation of pressure in a vertical plane. Yes, I want everyone to respond. There is a simple basic question on your screen. In case of static fluid, will the pressure vary linearly with depth or height? P is a function of Z. Is it linear or non-linear? Prabhat is saying yes. What about others? Prabhat, let me clear you. The fluid can be of two types. One is incompressible fluid. Another can be compressible fluid, isn't it? So if we are talking about incompressible fluid, which is having the constant density throughout, then the pressure variation will be linear with depth or height. But if we talk about compressible fluid, where the pressure, where the density of the fluid is a function of temperature as well as pressure, in that case, the variation of pressure with depth or height is non-linear. It is exponential in nature. So the answer, technically speaking, the answer to this question will be no. Do you understand it? Because it will be linear only in case of incompressible fluid. But for compressible fluid, the variation will not be linear. It is exponential in nature. So there is a question number 1 on your screen. The pressure is nothing but, what is pressure? Pressure is force per unit area, normal force per unit area. The unit is Newton per meter square or Pascal. That is the SI unit of pressure. Force and area are always perpendicular to each other. The normal force exerted by the fluid per unit area is called as pressure of the fluid at that particular point. Force per unit area. So there are different units of pressure. We need to find out which of the unit is representing the least pressure. Can you guys solve the question? Can you quickly solve it? Yes? There is a unit of pressure called as bar, and 1 bar is equal to 10 to the power 5 Pascal, right? So if we want all the unit, if we convert all the units in a single unit, then only we can compare them. Then only we can compare. If you can convert everyone in the single unit, like Pascal, so 1 millibar is equal to 10 to the power minus 3 bar, and 1 bar is equal to 10 to the power 5 Pascal. So it will be 100 Pascal, isn't it? Option A says 100 Pascal. 1 millimeter of mercury, you should convert the mercury head pressure in terms of mercury head in terms of Pascal by using this formula rho gh. Pressure is given by rho into g into h because it is in terms of mercury head. So 13.6 into 10 to the power 3 is the density of mercury. G, let me take as 10 into h. Height is 1 millimeter, that is 10 to the power minus 3 meter. If you put all the parameter in their SI unit, then you will get the unknown in its SI unit. So it will be 136 Pascal. B says 136 Pascal. 1 Newton per meter square, per millimeter square. If we convert it into Newton per meter square, then it will become Pascal. So 1 millimeter is equal to 10 to the power minus 3 meter square. So it will be 10 to the power 6 Pascal. 10 to the power 6. Hi Anirudh. Good evening. Welcome. Good evening everyone. Namaskar. Adab. Shubh Sandhya. Please settle down fast and try to solve the questions which are there on the screen. Another unit of measuring the pressure is kilogram force per centimeter square. 1 kgf is 10 Newton or 9.81 Newton. Let me take G as 10. To keep the analysis simple, G is taken as 10 meter per second square. To keep the calculation simple. And 1 centimeter is 10 to the power minus 2. So that will be Newton per meter square. So how much is that? 10 into 10 to the power 4. So it will be 10 to the power 5 Pascal, isn't it? So the maximum, which one of them represents the least pressure? Isn't it option A? Isn't it option A? Millibar is the least pressure out of these. So if I write the increasing order of pressure, if we write in increasing order, A is minimum, then B, then D, and finally C. This will be the correct order of pressure intensity. Yes, Anirudh. Sorry, Anubhav. It is not Anirudh, Anubhav. Yes, Anubhav. Well done. Good, good, good. Keep it up. The next question on your screen. Question number 2. A hydraulic press has a ram of 15 centimeter diameter and plunger of 1.5 centimeter diameter. Hydraulic press or hydraulic lift is based on the concept of Pascal law. It is based on Pascal law. So how the hydraulic press works? There is a static liquid in an arrangement. There is a plunger and there is a ram. The area of ram is large and area of plunger is small. This is the piston. And here heavy objects can be lifted easily. That is how it works. To lift the heavy objects, there is a static fluid kept in the arrangement. This is called as ram and this is called as plunger. And according to Pascal law, if there is a static fluid, in case of static fluid, or we can say any 2 points at same elevation, if there are 2 points at the same elevation, in the continuous mass of same static fluid will have same pressure. Pressure at 1 is equal to pressure at 2. If the points are having same elevation and the points are joined by the continuous mass of same static fluid, they will have same pressure. And can we say P1 is equal to F1 by A1 and P2 is equal to F2 by A2. A2 is the area of the ram and A1 is the area of the plunger. Can we write it as F1 by A1 is equal to F2 by A2? Isn't it? The question is, it is required to lift a mass of 1000 kg. So the mass is 1000 kg. It means we want F2 to be 1000 multiplied by 10, m into g. F2 should be equal to m into g. Yes, can you solve it? The force required on the plunger. The question is to find out F1. F1 is equal to F2 multiplied by A1 by A2. And what is A1 by A2? Because the diameters are given. A1 is pi by 4 d1 is square. A2 is the value of pi by 4 d2 square. So F1 will be equal to F2, that is 1000 multiplied by 10. Can we take 10 as acceleration due to gravity? F2 is equal to m into g. F2 will be equal to m into g into d1 by d2 whole square. What is d1? The diameter of the plunger is 1.5 centimeter. 1.5 divided by what is d2? Diameter of the ram is 15 centimeter. Then square. So it will be 1000 into 10 divided by 100, isn't it? F1 will be equal to 1000 into 10 divided by 100 Newton. Do you agree or not? So how much is that? 100 cancel out, and the answer will be 100 Newton. The correct answer is option A. The pressure will remain same at both the location 1 and 2, because the points 1 and 2 are joined by the continuous mass of same static fluid. I hope this is clear. Do not take A1 as 1.5. Don't take A2 as 15, because area is pi by 4 d square. Diameter is given, not the area. Most of the students commit mistake here. And another point where students commit mistake, the mass is given, not the weight. It is the mass is given to lift, not the weight. So if we want to convert it into weight, multiplied with acceleration due to gravity. The next question on the screen. Read the next one. I hope this is clear. If you have any doubt, it is open from the top. If anybody is having any doubt, anything to ask, you are most welcome. You can raise your concern through the comment section. Otherwise, I want you guys to let me know the answer. In the figure shown, air is contained in the pipe. The fluid contained is air. This is the pipe. And water is the manometric liquid. The pressure at A approximately is, the unit of pressure should be pressure head of water. The unit should be pressure head of water. Yes, can you solve it? Here the pressure is P atm. It is open to atmosphere. The pressure is P atm, or the gauge pressure is 0. Gauge pressure will be 0. The manometer is connected normal to the flow. So it will measure the static pressure of the liquid or air. It will measure the static pressure of air. I am waiting for your answer. Yes. Solve it quickly and do let me know the answer. Do you understand that the density of air is around 1 kg per meter cube? The density of air is very small compared to the liquid. And that is why the variation of pressure in case of air is very small. Because the density of air is very small, pressure variation is very small, negligible. Because pressure depends on the density, variation of pressure. P is given by rho g h according to hydrostatic law. So density, more is the density, more will be the variation in pressure in the same distance. So the variation of variation is very less, which can be ignored. If it is a gas, the pressure variation can be ignored. Do you understand it? Do you guys understand it? Sumit, how did you get option D? Are you getting option D? Are you guys getting option D? Hello, happy something. So let me assume the pressure at A is PA. This is 50 mark series, and in next 40 days, or it is the 40 days series where we will ensure your 50 marks. We will discuss all those important topics from the subjects which will help you to score at least 50 marks in your GATE examination. That is the agenda of this series. So pressure at A is PA. So can we write the pressure equation? PA, we are traveling in downward direction. Then density of air into G into H, 200 millimeter, that is 0.2. Pressure here will be same as pressure here, isn't it? And here also there is a air. Or we can say is equal to 0 plus density of air into G into 0.5. Are you getting it? So what is the value of PA? This will give you the gauge pressure. So density of air into G, let me take it as 10 into 0.5 minus 0.2. How much is that? 0.3. 0.3 into that. So gauge pressure will be are you getting option D? 4901 Pascal. How you are getting 4901 Pascal? What we can do is, if we ignore the pressure variation in air, so can we say pressure at A will be same as atmospheric pressure? Yes, Sumit, good evening. Pressure at A is PATM, isn't it? Because the variation of pressure in air is negligible. Pressure at A is almost PATM because the density of air is very, very small. It is almost 1 kg per meter cube. So the pressure at A is PATM and atmospheric pressure is around 10.14 meter of water absolute. Atmospheric pressure in terms of, if we write atmospheric pressure in terms of water head, do you know atmospheric pressure can be written as 760 millimeter of mercury. Atmospheric pressure can be written as 10.3 meter of water. This is the atmospheric pressure. So it is close to 10.14 meter of water absolute. So option A will be the correct answer for this one. Option A will be the right answer. It will not be option D. Do you guys understand it? It is almost 3 Pascal. Gauge pressure is 3 Pascal. Gauge pressure is 3 Pascal. Or we can say 0.3 meter of water. Gauge pressure is not negative. C cannot be true, B cannot be true. And it is the absolute pressure is almost atmospheric pressure. That is why. Kroparas, this series is for 40 days. We have planned this series for 40 days. Strength of materials had already been covered. Then it is the fluid mechanics for next 3 sessions. Then the technical subjects which will be different for civil engineers, which will be different for mechanical engineers. So the next 3 sessions will be common for civil as well as not 3 sessions. Total 6 sessions. 3 sessions I am going to take and 2 sessions Joshi sir will be taking. So there will be total 5 sessions from the fluid mechanics. 5 sessions you have already had from the strength of materials. So the series will continue for 40 days. right? There is the next question, beautiful question. Can I get the answer to this question? This is point A, let us say this is point B. The manometer shown in figure connects two pipes A and B. From the figure, what can we conclude? I want the answer from each one of you. Do not get afraid of committing mistake, because learning is never done without mistakes, without errors, without the defects. So be ready to commit as many mistakes as possible, so that you will be able to learn from your own mistakes. If somebody will tell you, tell the explanation, you will not understand this. But by doing it yourself, committing the mistakes and rectifying your mistakes will give you the better clarity of the concepts. Yes? Can I know the answer? This question looks very simple. Let me tell you, in GATE examination, you are going to expect the questions which will look very simple in the first observation, but there is always a twist in each and every question. The manometer shown in figure connect the two pipes A and B. The two pipes are at a same level. Yes. And the manometric fluid deflection. This is the manometric fluid. Let me call it the density of the manometric fluid as rho m. So the level of the manometric fluid in both the limbs is same. So if we write the pressure equation, the pressure at A is, let us say, PA, pressure at B is PB. So we start with PA, we are traveling in downward direction. According to hydrostatic law, in a static incompressible fluid, pressure increases linearly with depth. So pressure will be more than PA. Then density of the fluid A into G into H. We have reached here. This should be equal to, start from point B, pressure at point B is PB. We are traveling in downward direction, so plus. Now we are traveling in another fluid, because another pipe, another fluid. Rho B into G into same depth we are traveling. This is our pressure equation. This pressure at X will be equal to pressure at Y according to Pascal law. Pressure at X and Y will be equal according to Pascal law. So can we write PA minus PB as, what is PA minus PB? That is rho B minus rho A into G into H. Do you understand it? Rho B minus rho A into G into H. Now PA will be equal to PB. So there, the possibility will be PA is equal to PB if rho A is equal to rho B. Do you agree? Or we can say PA will be greater than PB if rho B is greater than rho A. Or we can say PA will be less than PB if rho B is less than rho A. So all these three can be possible. All the three options can be possible. Then the correct answer will be insufficient data. If we would have known the density of A and B, density of A is not known, density of the fluid B is not known. If we would have known the density of A and B, we could have get the correct answer. I hope it is clear to everyone. The next question, this question was asked previously in civil engineering GATE paper. But this question is very beautiful, very interesting. It is all about writing the pressure equation using the Pascal law correctly and using the hydrostatic law correctly. Right? Can you solve it? There are 2 points A and B. There are 2 points. There is a fluid flowing from A to B, a pipe carrying water. The fluid is water, is attached to a differential gauge, deflection in mercury gauge. This fluid is mercury. The deflection in the mercury gauge, this distance is 0.6 meter. Then what will be the value of pressure difference PA and PB? What will be the pressure difference PA and PB? Can you solve it? Two things you need to understand here. One is your pressure equation must be in terms of water head. because A, B, C, three options are there in terms of water head, right? And then you should write the pressure equation correctly. You should be able to know, or you should be able to apply how to convert one fluid column into another giving the same pressure. We can say rho 1 H1 should be equal to rho 2 H2. This is how conversion of one fluid column is done into another. S1 H1 is equal to S2 H2, which will give you the same pressure. Yes, I am waiting for your answer. We need to find out the pressure difference between A and B. Shall I write the pressure equation? Let us start with point A and let me assume this height to be H. Let me assume this height to be H. So if we want to find out the pressure difference between A and B, we will write the pressure equation using the jumping method. Try to understand the method with your full dedication, with your full concentration, because once you are comfortable with pressure equation, then you will be able to write the pressure equation for any type of situation, any complicated situation even. And in dynamics also, in fluid dynamics also, the writing the pressure equation is very, very important. It is not only limited to the statics. The concept is not limited only to the fluid statics, but in fluid dynamics also, whenever we want to find out the static pressure difference between any 2 points in the flowing fluid, we always write the pressure equation. So starting from point A, the pressure at A is PA in terms of meter of water. We are writing the pressure equation in meter of water. So now we are traveling in upward direction. Whenever we travel in upward direction in a static fluid, because in this manometer or in this tube, the fluid is static. So we are traveling in upward direction in a static fluid, pressure decreases with height according to hydrostatic law. So the pressure will be less than PA. And we are traveling in water. So no need to convert water into other fluid column, because our objective is to write the pressure equation in terms of water only. So the height of water we are traveling to reach here is H. Now can we jump from this point to this point? According to Pascal law, these 2 points will have exactly same pressure. Why? Because these 2 points are joined by the continuous mass of same static fluid and lying in the same horizontal plane. So this point will also have the same pressure, which I have already mentioned here. Now, can we jump from this point to this point also? These 2 points will also have same pressure. Why? Because these 2 points are also lying at the same horizontal plane and joined by the continuous mass of same static fluid. That is Pascal law. Now we are here. Now from here we are traveling in upward direction. Why? Because we cannot jump from here to here. These 2 points will not have same pressure. So because we are traveling in upward direction, then minus sign. And we are traveling in Mercury. How much height? Height of Mercury we are traveling is 0.6 meter. Now we need to convert this Mercury height into water height giving the same pressure. So the specific gravity of Mercury is 13.6 and the height of Mercury is 0.6, and divided by specific gravity of water will make it head of water giving the same pressure. Specific gravity of water is 1. Now we are here. Now we can again jump from here to here, because these 2 points will have same pressure again. Joined same horizontal plane, joined by the continuous mass of same static fluid. Now this point will have the same pressure. We do not change the pressure equation. Now from here we are traveling in downward direction. So now the sign will be plus. And we are traveling in water now. How much? 0.6 meter. Further moving in downward direction, further there will be an increase in pressure. And this height is H. We have reached at point B. This expression should be equal to pressure at B. Do you guys understand this pressure equation? This expression, each and every term in this expression is in terms of pressure head of water. I hope this is clear. Minus H and plus H will get cancelled out. So if we want to write PA minus PB, it will simply be 13.6 minus 1 into 0.6 meter of water. So 12.6 into 0.6 meter of water. What will be the answer? This will be the correct answer. Can you solve it and let me know? Can you guys solve it and let me know? And if you have any doubt in writing the pressure equation, you can just let me know through the comment section. So what is the correct answer? Give me the answer quickly. Let me know the answer. Is it 7.56 meter of water or 75.7? It cannot be 75.76 because 12.6 into 0.6, it will be less than 12.6. Is it 8.16 meter of water or not? That is also incorrect. So many students get C. C is not the right answer. Sumit, C will not be the correct answer. Do not jump to the conclusion. Some of the students start writing Pa minus Pb is equal to density of mercury into G into H, that is 0.6. I don't know why. Water will also come into the expression because the flowing fluid is water. The density of water will also be equally important here. The next question. Solve the next one. A pressure gauge. Do you know what is a pressure gauge? Pressure gauge is an instrument which is used to measure the gauge pressure of a fluid. It always measures the gauge pressure. The pressure gauge reads 57.4 kilopascal and 80 kilopascal respectively at heights of 8 meter and 5 meter fitted on the side of a tank filled with liquid in kg per meter cube. We need to find out the density of the liquid. The question is to find out, there is a tank, let us say at 8 meter height, at 5 meter height, there is a pressure gauge. It is giving a reading of 80 kilopascal, and at 8 meter height, there is another pressure gauge. It is giving a reading of 57.4 kilopascal. So what will be the density of the liquid? Can we write the pressure equation? If I take this as point A, this as point B. So can we say pressure at A, we are traveling in upward direction, minus density of the liquid into G into this distance is 8 minus 5 is equal to pressure at B, isn't it? So density of the liquid into 9.81 into 3 is equal to Pa minus Pb. And what is Pa minus Pb? 80 minus 57.4 into 10 to the power 3. Can you solve it? Can you find out the density of the liquid? Density of the liquid will be how much? If you put all the parameter in their SI unit, your answer will be in kg per meter cube. Yes, Anubhav, well done. What about others? A person who never tries anything, or a person who never commit any mistake, means he had never tried anything new. So you should not get afraid of committing mistake. Mistakes teaches you better. So do let me know the answer. If you are incorrect, I will correct you. And if you are correct, then you will develop the confidence. So both ways it will be helping you to improve your fundamentals. So it will be 768. Are you getting 768? How many of you are getting 768? Yes, Sumit, Anubhav. What about others? The next question, this will be your assignment question. This question is very much similar to question number 1. Try to get me the answer. It is MSQ actually. This is MSQ. You need to find out the minimum pressure and the maximum pressure out of these 4 values. So what you are supposed to do is, you need to convert each and every pressure in a single unit, then only you can compare them. So you can easily find out the minimum pressure and the maximum pressure. I hope you will be able to do it. And do let me know your answer through my Telegram channel. This is again a beautiful question. The next question, give it a try. Every one of you. There is oil, there is water, there are 2 fluids. It is inverted manometer. There are two fluids. The manometric fluid is oil, which is having the specific gravity 0.98, and the another fluid is water. This is also water. Another fluid is water, which is having the specific gravity 1. In the setup shown in figure, assuming the specific weight of water is 10 kilonewton per meter cube. What is the specific weight? That is density of water into G. That is called as specific weight. And if it is given in kilonewton, so it is 10 to the power 3 into 10 Newton per meter cube. So that is why it will be 10 kilonewton. So G has to be taken as 10. So indirectly it is mentioned that G you are supposed to take as 10. The pressure difference between the 2 points A and B, PA minus PB will be. The pressure difference PA minus PB will be. Can you find out the pressure difference PA minus PB? Yes. Are you able to see the figure, or shall I hide myself? So I will be having another session back to back on this Byjus app. At 6 p.m. I will be going to have another session on Byjus app for ISRO practice, for ISRO exam. So those who want to be part of this 6 p.m. session, you can join me on the Byjus app. We will revise all the formula for statics and kinematics. If you are uncomfortable with the formula of statics and kinematics, you can join me. So in next 5 minutes, I will stop here from here, and I will join sharp at 6 on our Byjus app. That is again the free session. So can you write the pressure equation? So pressure at A is assumed to be PA. We are traveling in upward direction. One single sign will make your answer incorrect. PA minus, we are traveling in upward direction in water. So density of water into G into how much height we are traveling? 0.5 meter. We are here. We are further traveling in upward direction, again minus. Now we are traveling in oil, density of oil into G into again 50 centimeter, 0.5. Now we can jump from here to here, isn't it? These 2 points will definitely have same pressure because they are joined by the continuous mass of same static fluid. Now we are traveling in downward direction, so plus, and we are traveling in water, so density of water into G into 100 centimeter, that is 1 meter, is equal to our destination is PB. So PA minus PB is equal to, G is taken as 10. G will be taken as 10. So it will be density of water into G. So it is 1000. Sorry, it will be negative. In the right hand side, it will become negative. So what will be the expression? It is density of water. Can we write density of oil into G into 0.5? Then it will be minus density of water into G into 0.5, isn't it? It will be negative. Your answer should be negative. So it will be 0.5 into 10 into density of oil minus density of water. So it will be 980 minus 1000. Density of oil will be 980. Density of water will be 1000. Density of oil will be 980. Density of water will be 1000. So it will be 20 minus 20. So minus 20 into 5 Newton per meter square, isn't it? Your answer will be minus 20 into 5. Density of water will be 1000 because the specific gravity of water is given. Density of oil will be 980 because the specific gravity is given as 0.98. So your answer will be minus 100. Sumit, it will not be B. It will be option D is the correct answer. Option D will be the right answer. I hope this is clear to everyone. Are you able to understand this? Hi Choresia ji, welcome. How are you? The next question. Another question. Try to solve this one. The pressure at the base of mountain is 650 millimeter of mercury. The unit is given in terms of mercury head. And at the top of the mountain, it is again in mercury head 500 millimeter. Find the height of the mountain if the density of air is taken as 1 kilogram per meter cube. Let me assume this as mountain. This is the top, point A. This is the base, point B. So pressure at A is 500 millimeter of mercury. Pressure at B is 650 millimeter of mercury. What will be the height of mountain? If there is air, the fluid is air. The fluid is air. So if we write the pressure equation, if we start from point A, PA, we are traveling in downward direction plus density of air into G into H is equal to PB. Either write this way or you can start from point B, PB minus density of air. If we start from point B and traveling in upward direction, there will be a negative sign, into G into H is equal to PA. So rho GH will give you the pressure in Pascal. So put all the parameter in terms of Pascal. What is the pressure at B? That is 13,600 into 9.81 into 500 mm. So 0.5 minus density of air. Let me write. So PB is density of mercury into G into 0. At point B it is 650, sorry, 0.65 minus density of air into G into H is equal to rho of mercury into G into 0.5. So G getting cancelled out from each and every term. So H will be equal to density of mercury 0.65 minus 0.5 upon density of air. That will give you the answer in meter. What is the correct answer? What will be the answer? Can you get me the answer? So H will be equal to, what is the density of mercury? 13,600 divided by density of air is 1 into what is 0.65 minus 0.5? $0.15. So it is 136 into 15 meter. How much is that? 136 into 15 meter. What is the answer? 2040 meter. Option C will be the correct answer. It is neither B nor D. Sumit, the correct answer is option C, isn't it? So that is all from my side. Please try to solve these questions. Some more questions I am giving you as an assignment. Try to solve these questions, and if you have any doubt, you can speak to me, you can write me the mail, or you can connect with me through my Telegram channel. Another assignment, try to solve this. I hope you guys have become a little comfortable with the pressure equation, right? Another question, try to solve these questions. The more questions you practice, the more comfortable you become with the concept. Always remember, an expert in anything was once a beginner. So even if you are not too confident with your concepts, with your fundamentals, if you will keep working hard in the right direction with your full positivity, full dedication and hard work, definitely you will become expert gradually in the concept. So the next class on 12th of June at 5 p.m. again I will meet you for the another very beautiful topic of fluid statics, important topic of fluid statics, that is hydrostatic force and the concept of buoyancy. All right, and do not forget to join me at 6 p.m. for the ISRO 2023 formula revision for statics and kinematics on Byjus app. So see you at 6 if you are interested. Otherwise, I will see you on day after tomorrow. I will see you day after tomorrow for this YouTube session. Till then, enjoy, take care, have a good day and a great career ahead. Thank you guys for joining in. See you soon. Jai Hind, take care, stay safe, stay motivated.